Alright, what we're going to do today is we're going to talk about complex numbers. Complex numbers, guys, are obviously numbers that are a little bit more complex. They're used a lot in electrical engineering. So, for any of you want to be engineers, electrical engineers, it's a nice little warm up here to what you're going to get into college. So, what makes a number complex? So, imaginaries. That is what makes a number complex, is imaginary. So what is an imaginary number? Essentially, guys, anytime you have the square root of a negative number, it's essentially imaginary. And why is that? Because if you remember what a square root actually does, a square root says what times itself will give me the radicand, what's inside. So like when I ask you what times itself is the square root of 25, your answer to me is hopefully positive and negative 5, because a positive 5 times a positive 5 is a 25, and a negative 5 times a negative 5 is a 25. Okay? So when you take a square root of a positive number, you usually get two answers. But when you take a square root of a negative number, it's actually impossible, because there is no number that times itself will ever give you a negative number. And if you think about it, two positives will give you a positive, and two negatives will give you a negative. So two numbers can never multiply themselves to give you a negative number. So the way we fix that is by talking about, well, it's imaginary. Well, all you have to do, all you really do, is you say, fine, if I'm taking the square root of a negative 4, what I'm going to do is just change this to a positive 4, but then I'm going to add this little I at the end of it. And so now I know my answer itself is imaginary. So then ask yourself, fine, what's the square root of positive 4? Well, that's a positive and a negative 2, in this case I, because it's imaginary. So that's it. So we have some two rules. I is essentially equal to the square root of negative 1, and then therefore I squared is equal to a negative 1, because if you square a square root, it cancels the root, and you're left with the inside. So that's how we're going to deal with today. We're going to deal with negative um, imaginary numbers, okay? So a complex number is a number that has both a real part and an imaginary part. Okay, so a complex number has two parts to it. It has a real part and it has an imaginary number. So essentially, that looks sometimes like, for instance, 2 plus 3i. So there's two parts to this number: a real part, which is my 2, and then the imaginary 3 right here. Um, so that is what a complex number is. Okay. And we already said imaginary numbers are any number times I. So for instance, this one is 2i, so 2 times I. And then a complex conjugate are two complex numbers in the form a plus bi and a minus bi. So a complex conjugate, we're going to talk about later, is the same complex number, but one's plus, one's minus. Okay? All right. So we have some properties here. And one of them is a property that I just told you. If r is a positive real number, then the square root of negative r is I square root of r. Basically, anytime you have a negative inside the radical, replace it with an I on the outside. So if I asked you what's the square root of negative 3, you would just tell me I square root of 3, or square root of 3i. It doesn't really matter um, where you put the I, because it's still being multiplied, okay? Property 2, by property 1, it follows that I square root of r squared is negative r. So basically, anytime you have an I squared, it's always replaced by negative 1. So think about it this way. If I square root of 3 squared, then that means that this squared goes to both. So that's I squared times 3, because if you square the square root of 3, the radical goes away. And so basically what I'm telling you is this: anytime you have I squared, then this is equal to negative 1. Okay, so then you get an answer of just negative 1 times 3, which is negative 3. So these are the two properties that we're going to be using throughout this lesson. Okay, let's start simple. Let's solve this equation. And so remember, anytime you're solving, you're always going to follow the rule, which is SADMAP, which is PEMDAS backwards. So basically, you want to get x by itself. getting rid of any addition or subtraction, and then getting rid of any division or multiplication, then getting rid of any exponents, and then parentheses if you have anything left. Okay, so using our SAD map, let's solve 2x squared plus 11 equals to negative 37. Okay, so first we are going to subtract 11 from both sides. That'll cancel. That'll leave me with 2x squared equals to negative 37 minus 11, which is a negative 48. Okay, and then I want my x by itself, so I get rid of any division or multiplication. In this case, I have to get rid of this times 2, so I will divide both sides by 2. So I'll be left with x squared equals 2. Negative 48 divided by 2 is negative 24. And then now I'll get rid of any exponent. The way I do that is I want to square root both sides. So then x is equal to the square root of negative 24. Now this is where the problem runs in. Just like what we discussed before, I cannot take a square root of a negative number. So then what I'm going to do is say, fine, this is really the square root of 24, I. Just put that I, now it's positive, now I can deal with the square root of 24. Well, if you recall, square root of 24 is not a perfect square, therefore it's not a whole number, and we don't want decimals. So, going back from our previous lessons, what do I do with the square root of 24? Well, you want to probably try and reduce it if you can. Meaning, can I factor it with a perfect square and another number? And you can. Square root of 24 is the square root of 4 times 6, which would give me 2 square root 6i. So my answer is x equals to 2 square root 6i. Actually, two answers, a positive and a negative 2 square root 6i. Okay, let's try our next example. Simpler, actually. I have x squared equals to negative 13. So there's not much to do here. You're going to square root both sides. And that gives me that x is equal to the square root of negative 13, which I can't do. So then it just becomes the square root of 13i. And then you ask yourself, can I fix this? Can I fix the square root of 13? Again, square root of 13 is a decimal, which we don't want. So can I factor this? And in the end, actually, no, you can't. So this is your answer. This is your answer. And I have to put a positive and a negative. Okay? A positive and a negative. Anytime you take a square root, you always get two answers. Okay? Have a checkpoint here. So I have 3x squared minus 7 equals to negative 31. So PEMDAS, or SADMAP rather. So you're going to add 7 first. That'll give you 3x squared equals to negative 31 plus 7 is negative 24. And then to get x by itself, you'll divide by 3. So x squared is equal to negative 8. X is equal to the square root of negative 8, which is the square root of 8i. And then ask yourself, can I fix the square root of 8? You should be able to. The square root of 8 is the same thing as 4 times 2. And 4 being my perfect square. So you'll get 2 square root 2i. 2 square root 2i. Alright, so let's talk about adding and subtracting complex numbers. When you add or subtract the real parts and then you add or subtract the imaginary parts, you keep them separate. Essentially, guys, when you're adding or subtracting complex numbers, essentially you're combining like terms. So exactly what I just said, you have the things that are alike, can combine with each other, and that's it. So here I have a complex number. Remember, in a complex number there's two parts. There's a real part and then there's an imaginary part. And there's a real part and an imaginary part. So only combine what you can. And since you're just adding, you're just combining like terms. So 8 plus 5, of course, is 13. And then I have a negative 1i and a positive 4i. And think about it, if you have a negative 1i and a positive 4i, so that means you have a positive 3i. And that's it. And again, there's my complex. I end up with another complex number. It has a real part, has an imaginary part. Okay? Now when you're subtracting, the only difference is, when you're subtracting is, this minus sign comes into play. So what you're going to do is you're going to distribute this minus sign and then add instead. So you'll have a new equation that says 7 minus 6i. And then I'm going to change this to plus, but then my complex number changes to a negative 3 plus 6i. Now do exactly what we just did before. Put the real parts together, put the imaginary parts together. So I have a 7 and a negative 3. Adding, remember I'm just adding, so that would give me a 4. And then I have a positive 6i, I'm sorry, a negative 6i and a positive 6i. So that actually, they cancel. So that leaves me with just a 4. So this actually is just going to leave me with a real part of a 4. I mean, I could write it as a complex number, but it would just be plus 0i. Okay? But it doesn't matter. They're the same thing. So there's only a real part in this situation. Okay? Now to multiply complex numbers, we're going to do exactly. We're going to either distribute or FOIL if we have to. As I have before, the only thing that's going to come into play here is that property that I talked about earlier. So, say I have here 4i times negative 6 plus I. Okay, you're going to distribute like you would before. Okay, treat this I like an x, like it's a variable. Okay, so that would give me what? That should give me negative 24i, and then it should give me a plus 4i squared. Okay, the only thing is, if you remember the property we talked about earlier, property number 2, it says what? That I squared is always replaced by a negative 1. So I squared is always replaced by a negative 1. So what I have here is I have negative 24i plus 4, and then because of that I squared, it's really a negative 1. So what I really have is negative 24i minus 4. So notice that this is now a complex number. I have a real part and I have an imaginary part. And if you wanted to, you can write it in the correct order, which would be a negative 4 minus 24i. Here's my real part, here's my imaginary part. So when you're multiplying complex numbers, just be on the lookout for this I squared, okay? This I squared always gets replaced with a negative 1, and then it just changes your, most likely, to a real number. Let's continue. So now I have something different. It's not going to be distributive. Notice they're multiplying times each other. So this is your FOIL method. Basically, everything in the front gets multiplied to everything in the back. Okay? So, negative 3i times 2i, what is that? That would be 6i squared. Negative 3i times 7, that would be a 21i. Negative 2i times 2i, that would be a negative 4i. And then negative 2 times positive 7, that would give me a negative 14. And just like we have before, you're going to combine your like terms. So technically I have a 6i squared. I have a positive 21 and a negative 4. That would give me a positive, what? 17i. And then I have a minus 14. So this is what you think you have, but remember what our rule is. Anytime you have an I squared, it gets replaced with a negative 1. So really, does everybody understand that this is 6 times negative 1, which is a negative 6 plus 17i, and then I have a minus 14. And again, notice I now have 2 more like terms. These are both real numbers, the negative 6 and the negative 14, so I can combine them to give me a negative 20 plus 17i. So here's my complex number. It has a real part and it has a 17i, an imaginary part. Okay, so something we've done a million times, foiling. The only thing is combine like terms, and don't forget about that I squared. So your answer should never have an I squared in it, because it should always be replaced by a negative 1. What about dividing complex numbers? Well, we have 2 plus 3i divided by 4 minus 2i. So, when you divide complex numbers, what you're going to do is you want to multiply instead. Multiplying is easier than dividing. So what you're going to do is you're going to multiply by what we call the complex conjugate. And if you recall from the beginning, all the complex conjugate is the opposite of the equation. So now, it's only going to be the complex conjugate of the denominator. So I'm going to change this to 4 plus 2i. And I'm going to do this 4 plus 2i. Now notice that it's the same on both top and bottom. Why? Because technically this is 1. This is 1. And anytime you multiply by 1, you are not changing the equation, because anything times 1 is always itself. So what I'm going to do is I'm multiplying my problem by 1, but it's a unique 1. It's my complex conjugate. Now, how do you multiply fractions? Well, straight across. Straight across. And if you notice, then this turns into a FOIL thing. So write out everything I have. I have 2 times 4, which is 8. I have 2 times 2i, which is 4i. I have 3i times 4, which is 12i. And then I have 2i times 3i, which is 6i squared. Okay? So here, same thing on the bottom. 4 times 4 is 16. 4 times 2i is 8i. Negative 2i times 4 is negative 8i. And then negative 2i times negative, or positive 2i is negative 4i squared. So this turns into exactly what we just did on the last one, just twice as much. Notice that because of the I squared, this is going to turn into a negative 6. Same thing here. This is going to turn into a positive 4. Basically, you just change the signs. And now combine your like terms. Okay? So I have a 8 and a negative 6, which is going to give me a 2. And I have a 4i and a 12i, which is going to give me a 16i. And then on the bottom, I don't know if you noticed that this is a positive 8i and a negative 8i. Those actually cancel. And this is always going to happen. Anytime you multiply a complex number times its conjugate, the middle parts are always going to cancel out. Always. So there's kind of a little trick here. All you really have to do are the front parts and the back parts, as long as they are complex conjugates. As long as they are conjugates. You really only have to do the front parts, you really only have to do the back parts. On the bottom only. On the tops, notice they were totally different, so I just had to FOIL anyway. But just to kind of save yourself some time, you could only do the 4 and the 4, which is a 16, and the negative 2i and the positive 2i, which would have given me my minus 4i squared, which turns into a positive 4. So here's what I have. I have a 16 and a positive 4, which would give me 20. Okay? Now you can continue to simplify this a little bit more. Notice that they're all even numbers. They're all divisible by 2. And as long as they are all 3 of them, 1, 2, 3, as long as all 3 of these numbers are divisible or reducible by the same number, you can do it. So if I reduce everything by 2, notice I'll get 1 plus 8i over 10. Okay? Let's keep going. Let's try the same thing. 3 minus 6i over 2i minus 4. So, what am I going to do here? I'm going to multiply this by the complex conjugate. So in this case, it would be 2i plus 4, 2i plus 4. Okay? FOIL the top, so that would give me what? 6i plus 12 minus 12i minus, oh, I'm sorry, 12i squared actually. 12i squared, and then that would be a minus 24i. And then I'm going to kind of use that trick that I just showed you on the bottom. Remember, so I know that because they're the same equation, but one's positive, one's negative, that the middle is going to cancel. So really, I'm just going to do 2i times 2i, which is 4i squared. and then I have a negative 4 and a positive 4, which is a negative 16. Okay, so now combine like terms. Notice that I have an I squared here, which is going to become a negative 1, which basically just changes this to a positive 12. Same thing here. I have an I squared. It's basically going to change this to a negative 4. So combine your like terms. I have a positive 12 and a positive 12, which is going to be a 24. I have a positive 6i and a negative 24i, which is going to be a negative 18i. And then on the bottom, I have a negative 4 and a negative 16, which is a negative 20. Okay? So, notice again, in this case, I can reduce all of them by 2 again, which would give me a 12 minus 9i over negative 10. And there's my final answer. There's my final simplification. Let's keep going. Let's talk about your complex solutions of your quadratic equations, okay? So if I had an x squared plus 4, okay? If I had an x squared plus 4, and I asked you to solve, again, if you're trying to solve, if you're trying to solve, you're trying to get x by itself. So what would you do first? Subtract the 4. So you would have x squared equals to negative 4. Square root it, so x is equal to the square root of negative 4. There's the problem, can't deal with that, so it's the square root of 4i. Don't forget, because what's the square root of 4? It's actually a positive and a negative 2i. Please do not forget, anytime you take a square root, you always get two answers, a positive and a negative. Okay? Let's kick it up a little bit here. I have 3x squared minus 2x plus 5 equals 0. So this is a little bit different equation, okay? This is in standard form. I have my ax squared, my bx, my c. So what I should try to do is factor. Let's see if I can factor. The rules of factoring say multiply a times c. So 3 times 5 is 15. So I need factors of positive 15 that'll add to a negative 2. Well, since I know it's a positive and they have to add to a negative, they both have to be negative, because two negatives will multiply to give me a positive, but they'll add to give me a negative. So give me some factors of 15. Well, negative 1 and negative 15, that doesn't add to negative 2. What about a negative 3 and a negative 5? Well, they do not add to a negative 2 either. They add to a negative 8. Any other factors of 15? No. So some students might say, well, if I make this positive, then that'll add to a negative 2. Yeah, but now that will not multiply to a positive 15. It'll give me a negative 15. So what actually happens here, guys, is this is not factorable. This is not factorable. So what that means is, what do I do? How do I solve an equation that I can't factor? Well, just like you did in Algebra 2, you're going to have to use the quadratic formula. You're going to have to use the quadratic formula. Okay, what's the quadratic formula? Well, negative b plus or minus square root b squared minus 4ac, all of that over 2a. Based on this equation, do you have what you need for this formula? Yeah. What's your a? Your a is 3, your b is negative 2, and your c is positive 5. Okay, so x equals a negative b. Well, I have a negative of a negative 2, which is going to change that to a positive 2, plus or minus the square root of negative 2 squared minus 4 times 3 times 5. All that over 2 times 3. Alright, well, we can do this like what we have before. Remember what I've told you? I only want you to do the radicand, what's on the inside, first. So if you just do what's negative 2 squared minus 4 times 3 times 5 in your calculator, you're going to end up with 2 plus or minus the square root of 56 negative 56, sorry, divided by 6. Okay. The thing is, it's this negative. The negative gives me the issue. So how do I fix it? Well, same way we've been doing this whole lesson. I can change it to 2 plus or minus the square root of 56 I over 6. Okay, so this could be your answer. However, you do have to look at this radical. Can you reduce the radical? In this case, yes, you can actually reduce square root of 56 is the same thing as 4 times 14. And 4 is my perfect square, so this actually comes out to 2 square root 14. So really your answer is 2 plus or minus 2 square root 14 I over 6. But again, if you look at these three numbers, notice I'm not looking inside the radical, so I'm looking at 1, 2, 3. Are they all reducible by the same number? And the answer, of course, is yes. I can reduce them all by 2. So that would give me 1 plus or minus square root of 14I over 3. And there's my final answer. There's my final answer. Okay? So this is probably the hardest that these kind of equations will get. You want to factor. If you can factor, then you'll have two equations that you can just separate and solve to equal to 0. And then if you can't factor, though, you're going to have to use your quadratic formula. It's just a regular quadratic formula, except that you may get a negative number here. And simple fix, just put the I, make it imaginary, and here is your complex answer. So, notice, I have two answers here. I have 1 plus the square root of 14i divided by 3, and 1 minus the square root of 14i divided by 3. And now we're going to practice. You're going to have a textbook page. Don't worry about it. You don't need the textbook. I copied it for you, and it will be online as well. You're going to do 2 through 44 evens only. So that works out to about 22 problems. Okay.